Welcome to this Engerati webinar. My name is Rose Bundock, Head of Commercial Content here at Engerati, and I'll be your host for this live session. Before we begin this case study webinar, I'd like to go through a couple of housekeeping items. Firstly, the presentation is available to download as a PDF file. You'll see on your screen there's a heading Event Resources, and you'll find the PDF under there. And you can also download it as an MP3 audio file for easy access. The webinar is also available on demand on Engerati, so you can share the key learnings from this webinar with your colleagues. At Engerati, we like to make the webinars as interactive as possible, so we encourage you to pose questions as we go along. So please submit them, and we'll tackle as many as possible in the Q&A allocated time at the end of the presentations. In this webinar, we'll be discussing monitoring Europe's low-voltage grid, an update on flexibility pilots. We're fortunate today to be joined by a representative of Dutch utility Enexis, Project Manager Wim Plum, who will update us on the pilot that Enexis is involved in. We're also joined by solutions provider Socomec of low voltage monitoring, and Nadej Claire, will infrastructure marketing manager, will represent Socomec. Wim, I believe you are kicking us off today, so we look forward to hearing your presentation. Over to you.
Okay, thank you, Rose. Yes, to start, I like to talk to you something about the distribution automation light. We have a new pilot in Enexis grid, and it is not only a pilot, it goes further the next years. And I will introduce you with this agenda to the next step. That's who is Enexis. I will start with it, then with a short introduction what the goals are from Enexis and how we will do to customers. The pilot experience from the first boxes we have placed it, and then further about the daily specification and daily challenges, and at last, how we think about the low voltage measurements. There's something going. Okay, who I am working 28 years by Enexis. So you have a photo at the right side. You see what's my face, and maybe you have meet me on some here at Congress. What is Enexis? Enexis is a regional network operator in the Netherlands. And we have some topics. We are responsible for the 2.6 million customers, and we would have a high reliability. We would do it safe, and we will one of the best of our country, and we will be one of the best in Europe. We want to do so. That's what our goals are. But what will we do to the sustainable energy? What's coming on to us? Most customers, when we have a lot of PV solar panels on our grid, the customers have no problems with that. They must have no problems when we have charging the cars, heating pumps. You can call everything what is with the sustainable energy. We must do something with it, and we must have that no people have problems with it. The reliability of the grid must be better and not worse. And we know that the next years the amount of electricity, the capacity of electricity will grow to second times or 3 times. How can Enexis do that? And one of the things is not only to more cable works, but also make the grid more intelligent. And therefore we have started some programs, and they are distribution automation on crucial points and a smart meter for customers. And the last black hole is the substations and the low voltage cables. And I will introduce you shortly in our grid. We have in our high voltage grid, we have monitoring, but also in the transport grid. And we started 2 years ago with distribution automation on crucial points in the ring form grids. And you see on the 2-3 points, it is possible with switches to switch on and off when there is a fault in our grid. We're steering this grid with this ring form, but we steer it with star. So it is possible after a fault to close the switch on and off. And in 2-3 minutes, it is possible to get customers new energy from the other line. Our not operational time of not getting electricity is going down from 25 minutes to 60 minutes. So it is a very good case to do this. The next step is that we are busy with the smart meter. And then, we have one problem. We know nothing about the other substation. And we have about 40,000. We didn't know what has happened there. And we didn't know what has happened at the low voltage cables and the public lighting. And, we have started 2 years ago with a DALI pilot. And DALI means distribution automation light. And it means we have no switches in such a substation, but we have only the intention to observe and maybe to switch on and off the light. The intent of the pilot we started was achievable price and quality. When you look today, the prices of the boxes are about 4,000 euros. When you must install 40,000 boxes, it's not payable. It's too. The business case is never positive. So that's one. The other one is, can we reduce the installing costs? Can you make a plug and play that you mount a box in a station and you are ready in 1 hour, 2 hours? And what I say, we must learn about it. Without a real positive business case, we have decided 1.5 years ago to install it at all our substations. That means that we have the next time a project for installing 40,000 boxes into 2025. In the DALI pilot, we have chosen 4 deliverance you see here on the picture. And we have installed them 300 boxes each on several places to learn about it. And we have also installed at difficult places. You see here the box in the middle of the door, and because there's no place in the station. So this we have look what is the possibility to place the boxes, and that we have not, but it is not possible. No, it is we want to do this. And measurements of this box, simple box, you see that you can, what we never see, that we see the 3 phases, and that 3 phases are loaded, or one specific and the other 2 normal. So you can change this load that some customers are more on one phase than on the other phase. So there were a lot of things to say. It is a good feeling to go further. And we have made the specification of the DALI box, and that's to measure the short circuit fault in the medium voltage grid. So you can better, we have on crucial points, we have the switch gear, but at the other station it is possible to measure where the fault in the cable is. So you can quicker go with our people to the place where the fault is. We will measure the low voltage and current from the transformer. Normally we have it with current meters, and we have 2 times a year we measure the current in a station, the maximum current in a station. Now we have much more things to know about. We will steer the public lighting, and that's especially, I think, in Holland, that we have in the station in the substation, that we have tone frequency steering, and the tone frequency steering is aging, and we will with the DALI box go to a new steering program. And optionally, and that's interesting, we will start to measure the current from the low voltage cables. Here, for the technical, people, you see one scheme what we measure with the box, and the most of the current and the power sensor are digital, but we have Modbus optional for the measuring from the low voltage cables. And we have tendered the box 1 year ago, and Micronica is the delivering partner of this box. And you see a small box, and it is started with a price with the pilot about 5,000, 4,000 euros, and now the box is in the price from 500 euros. So it is affordable to go further to install the boxes in the station. You see further that most of the cables are more plug and play, and so it is easy to install. On the right side you see here air fault relay for the medium voltage detection if there is a fault. What are the daily challenges? They must be affordable. Yeah. Installation, make a plug and play. We must do it one time right, and that means that they are distribution automation. Much of the time we must go a second or third time back. So we have introduced a handheld to see if we have the good measurements. We have a good place the sensor for measure the current and the voltage. So it is one time in the station and one time good. And security. Normally you say security. Do I need the security? Because it is only public lighting we switch it on and off. Now this system is coupled with our intern ET domain. You see on the right side where we have the sensor, here you have the DALI box, and we send with GPS to the OT, operational technology domain, and from there we go to the Internet Information Technology domain. So you must have several firewalls on several places for the security. And the other thing is, when we install in all that station the box, it must be safe. It must be no human problems for install a box. The time schedule, we have started in March 2015. With the pilot in 2016, we started with the further rollout. We have built in that 1.5 year the ICT platform. In October last month, we have installed the first boxes. There are now 3 boxes live. And in April 2018, we started the definitely rollout. And in 1 January 2019, we will install 6,000 boxes and 200 low voltage measurements. So we will see, is it possible to place it. This is in the next figure. I go very quick through it because it is much steps, but it gives the difficulty from the total process. In the DALI pilot, we have to say the measurements are going to the cloud. But now we have built a new our platform, and when you look and we go to the assignment, is the intake, and we will look how it is with watch in the station, and we give all the information to the GEN, our small world operation, geographical information of our grid. You see that some things are happening with all the process in the ECT and the other domains. And it's not that you say, okay, it is an easy way. We must do it on a right way, because the public lighting every evening must go on and off. So it is. This was terrible to build, and we have now the last workarounds, and then we can go full roll out with the other things. Here you see one picture with one installation we have installed 2 weeks ago. We have here the handheld of the terminal, and here is the Micronica box. And we must place this not in the beautiful station, in the big station, but also in small stations. And here you see one of the 40,000, not all the stations in Enexis are seen out like this, but most of them we have here the old current measurements, here the current transformers, and we need to install here a DALI box. And yeah, that's really go to do it. We hope we can do it. The next step we have is to measure the low voltage grids. And we started again like the pilot of the Daddy box. The pilot of the Daddy box was that we want to have first is it affordable? Is to install what are we doing with the data? And so we have started the last years with some pilots, and one of the pilots was with on the old method, and the old is that you have this one quick that you have something wrong, I think. Okay. You see here one installation of the measurement of the current transformers, and we have a low voltage installation in substation. Mostly we have more than 8 fields from 8 cable fields. When you have the old transformers and the old current transformers, you needed 8 times 3 phase is 24 current transformers. You need also 24 current transformers that knows that you have 2 lines to it, to communicate with it. And that means you have 48 cables, and you see it in the right screen, right screen, how many cables you have. And you must install it correctly at the box so that you have the good figure which measurements you have. So this installing costs much time, and much faults are there. So we have looked to other companies, and one of the companies is Socomec. And we have found this picture of Socomec, of this installing of Socomec, and attach the second speaker, so say a lot of Socomec. So I will not speak too much over this product, but it is a very good product to use it, and it is very quickly to install. We work with Rofki's coils. You need it not. You see, it is very flexible. You can put it on the cable, and after that you switch it the cable inside. It's a connector, and from this connector you are going to a box where you can get all the information. And we install this in the stations about 15 minutes. And one of the stations we have put also the Daddy box. We have here the Socomec installation at the upper side, and we have the Modbus. We have it connected to this Meconica box. We have a lot of data, but the last thing we are doing in the chain is to make a real fine dashboard, and that's not ready on this moment. But we have some things about the data quantity, because we are interested in how much data is it that we send from such a substation to our ICT platform. And every message is about 175 bytes. That's not much, but we have a lot of travel measurements for 50 minutes. And when you do that for 1 month, you get 9 megabits. And that's much. And when you do it with the thresholds, the alarms, we have set up a position of 1%. When the voltage or the current is going up or down, you get 205 megabits threshold alarms. So when you do this for a lot of stations, the data lake, we must have a bigger data lake than we have think about it. But I think that are the problem for the next years, and we hope we can start and go further with this, because there are some possibilities for low voltage measurement, because the business case is not yet positive, but we are thinking with this pilot that we can have a look into the energy balance, that we have the teeth of electricity for wheat plantation, that it will make our business case positive. Also, we have some charging squares that we know what has happened there, that we know the capacity of the cables are not overloaded. So we think the next months when we install this, that 200 low voltage measurement in our station, that we got lots of profit so to make a positive business case, and that we install in the rest of the stations, maybe not this year or in 2018, but when we go further, not the first 6,000, but the other 34,000 we must install, that we can do also the low voltage measurement. And I hope, I enjoy you with this story, because it's the last slide for me. So when there are questions, I will hear about it. Otherwise, I will give the word at Nadesh.
Yes. Yes, hello. So I'm Nadesh Claire. So first, thanks Wim for this very interesting presentation of your project. This DALI project, as we can see, is one of the most advanced low voltage smart grid project, setting up a complete OT and IT architecture. And to complete this information, I will now give more details on the low voltage monitoring, the electric sensors, which are the first element of a low voltage grid management system. So first, I'm Nadesh Claire. So in Socomec, I'm in charge of the energy and infrastructure market within the strategic marketing department of Socomec. And a few words on Socomec before starting. Socomec is a French independent manufacturer, expert in low voltage power and energy performance. We are now a group of 3,100 people with 27 subsidiaries. In France, for example, we are an historical supplier of EDF Group. I will start now to just coming back on the context and environment. As we saw it with the presentation of Enexis, everywhere now in Europe and in the world, the utilities have to face environmental politics, new issues regarding the climate and the introduction of renewables. And also the DSO with this all renewables injection need to respect the quality of energy delivered to the clients. And they would like also to optimize the OPEX and CAPEX within their organization. As Wim was saying, now we see that the last point where there is no data or little few data are the main are the MVLV substation and the low voltage cables. In traditional grids and in other grids, we see that in high voltage and medium voltage, we have a lot of information with the SCADA system and the monitoring solution. And at the opposite way, you have the smart meters, which are in rolling out to have better information on the different clients. But between both systems, there is today not very few information. And now these things are changing due to mainly about the massive injection of renewables, which are intermittent, and also which can create bidirectional currents feeding the medium voltage network. And all this network, all this different current could create some stress on the low voltage grid. Another main topic that we have seen in utilities, in other utilities also, for example, is the phase imbalance, which could create huge technical losses. Another point, to implement a low voltage monitoring system could help to detect the frauds, or what we call the non-technical losses. And now, and tomorrow, We see also with the development of smart buildings, smart city, and different topics, we see the development of the electric vehicles and their charging infrastructure. We see the development of the energy storage in smart building, in grids, and in different places. And now also we see the new market of peak shaving, the market of capacity for the different clients. All this will create a new constraint on the grid, and these are the main reasons to implement such low voltage monitoring. Let's see now what is this modular system and why it is so innovative today. We developed in Socomec a new concept of low voltage monitoring. Before we have this such box that you see on the left. This was a box where you have everything. So we have the current, the voltage, and the communication, and a display. And now we came from this concept to another one, and we split in different modules the different functions. So this concept has been really designed for multi-circuit installation to measure different points with a very easy and modular system with a plug-and-play solution. And like that, we have module. You can install in a substation only one module for the voltage. The number of current modules that you need, different, we have a complete range for that. And also now the display is just an option if you need it or not. All this module is linked through a specific bus, the yellow cable that you see. And also the main innovation is about the current sensor. The current sensor is already a main point for the installation, and in substation you can't cut the current. You need to operate in a live working environment, and all our system is really developed for that, to have a safe and secure installation very quickly, with all cables are now in RG12 or RG45. It is a very plug and play system. So on this slide, you can see all the different modules that we have. For example, we have all the voltage module, the current module, and all the different types of sensor which can be open or with a Rogowski coil. And in addition to this range, we have also gateways and WebView embedded in the gateways and a complete solution. This new system has been already designed for multi-circuit purpose. This is already what is installed, for example, when you want to monitor the different low voltage feeders in the substation. This is a flexible system because today, for example, a utility can decide to monitor 3 feeders on a substation, and tomorrow, if they want to monitor the 8 or 9 or 10 feeders, you just need to add a module and to add a plug-and-play solution with the bus. This system is also accurate and cost-effective, as we said already, because we see that this implementation is made in a quarter of time in comparison with existing technology. And this is a point that Wim told. When you have 4,000 or 6,000 substation, the time of installation is really, really important. This is so plug and play and connected. When you see, for example, the concept of on a smart low voltage feeder pillar that you can find in a substation, you see that you can monitor after the secondary of the transformer and one or all the low voltage feeder on the board. And this can be done so very, very easily. And you just need to add a box in the substation with all the connection to the different current transformer that you have. And all the modules can be only put in one or two very small DIN array, for example. After following what you want and what the utility, the operator wants, we can measure only the voltage current. We can also monitor any powers, and we can go up to the monitoring of the harmonic distortion on currents and voltage. So this is complete measurement and monitoring of the low voltage network. Another point that we see also is the temperature, the monitoring of the temperature of the substation and of the directly from the transformer. All this data can be directly monitored through the box and through a gateway. And we can also monitor the energy monitoring and energy quality. Here on this system, on this picture, you can see another type of low voltage board which has been totally monitored with such system. And you can see on the right the Golgowski coil directly on the low voltage cables. Now to come back on the architecture, we can see today that the substation in the different gateway in the substation are becoming connected to a cloud or to an IoT platform to have simple monitoring, some alarming report, and also an automatic setting. And this is really a trend that we see today is to develop this such solution for the low voltage grids. And now all the data are coming from a smart low voltage board in any substation to a digital monitoring platform through the monitoring and the cloud solution. And today and tomorrow we see that we are developing new tools, new apps to help the DSO to monitor and this low voltage grid by the visualization of the data first, like Wim was that we see on the presentation of Wim was the curve and the different current or voltage level. But also we can see all the alarms, because the alarms is the first interest for the operator is to know when something is going wrong on the load, on the transformer, on the phase unbalance, or such information. And after, we have also all the curves, all the details for the R&D department. And with this real-time data, we have a complete view of what is going on the network. To conclude, I would say that this type of innovative concept is adapted to the substation. Is what we see today in Enexis and also in other utility in Europe, which allow a better integration and an easiest integration of renewables, because like that the operator can see exactly what's going on. And also we use the new IoT technology with a cloud solution and a cloud connection with the low voltage data. And yes, this solution is flexible and can answer also to the economic purpose on the economic issues on the DSO, which can't at the same time, for example, monitor all the grid. The number of substation is very high, and we see with this type of flexible and scalable system that it is very easy to have an evolutive system. Yes. So thanks for your attention, and don't hesitate to ask any question if you have some.
Thank you, Nadège. We've had some questions through already, but there is still time to pose more, so please do. Wim, we've had a query from the audience asking for if you can expand on the business case. I mean, you mentioned it's not yet a positive business case. But what is the cost per station, and what are the financial benefits that you're seeing or expect to see?
That's a difficult question because I have not the real facts. But when we go back, we see that distribution automation will lead to 25 minutes of no giving electricity to 15 or 16 minutes. It costs about each station about 30,000 to 40,000 euros. And we say that business case is positive because the lost time goes through 25 to 50 minutes. And that means we install in our company about 3,000 substations. We are now about 1,500. And it means a cost aspect of about 90 million to 140 million euros. We are thinking now about DALI, Distribution Automation Light. We have not to change the switches. That's very expensive for the distribution automation. And we think to expend now about 500 euros for the DALI box, about 200 euros for the sensors, the current sensors. We need 100 euro for the earth fault relay. And then we have the installing cost. And the installing cost is about 6 hours we have calculated. So we think that each box is installed for a price for 1,300, 1,400 euros. And we have a positive business case for something what costs 30,000, 40,000. You go back in a smaller way, in a light way, so as we say with DALI, Distribution Automation Light, then we have no problem with the price about to 1,500 euros to install the box, because we know the benefits are the energy balancing. We know the problems in the future. We have about 3 billion euros of cable works in the ground. When the capacity is growing to 2 times, it means 6 billion euros. So that is such amount of money that a project like DALI, about 100 million euros, is nothing. So when you have the information of your grid, we think that a price for each station about 1,500 euros is normally. And then we have only the transformer current and the transformer voltage. And we think for the same price, that's realistic. We think in the future that for the same price, for about 1,500 euros, that it is possible to measure all the low voltage cables. Okay, we have started with a project with Interflex. We have started with other pilots. And the prices are raising from 5,000 euros to 2,500 euros. And we think when the amount is growing, when we say, now we say we want 200 measurement systems. But when we think about 1,000 or 2,000 or 5,000, I will think the price is going down to the 1,500 euros. And then what I say, then we have a good feeling, that's a good price. But we can never, I think in this way, because we have not the problems in our grid, that we must do it now. But we are thinking that we must do it for over 10 years. So, we have not the benefits yet, but we are thinking we are on the good way to be a smart grid operator for the future.
Thank you, Wim. Another question, obviously, the pilot is still ongoing, but what have been the greatest learnings so far from deployment?
That's that you go to other grid operator, that we normally have maintenance in our grid. And with installing this distribution automation components that observe our grid, it is more the outage that we are doing things, but not, we are going from proactive to reactive in our maintenance. Our people are more, what I say, plug and play, putting boxes, and this more that we have to going from outside to inside to more data acknowledges. Then in the way that we must do some things in the grid, working in the grid. We'll see over several years lesser cars with Enexis on it, but more people inside into office who are looking what are we doing with our kids.
Okay, so do you feel you're on the right track with this pilot? Do you feel this will be the solution to improve
I hope so.
the low voltage grid?
I hope so, Rose. And answer the question to the audience is, what are you thinking about it? Do you think it's a good way, or must we wait to Socomec or other companies have development other measurement systems?
I mean, Nadej, perhaps this is a good moment to bring you in because you obviously work with different utilities. And what other projects are you working on that's deploying a similar solution to this one?
Yes, we have. We are working with different utilities, low voltage grid operator in Europe. Some smaller, some bigger, but in different places. So in Netherlands, Enexis is very well advanced on this type of project, but we have a lot of implementation in Belgium because, for example, we have a lot of constraints due to the integration of renewables of PV. They've got a lot of PV generation. In other small utilities, we have implemented our solution in France, in the smaller municipality utilities, to have information on the grid, because today we have really no data on the low voltage substation. And also, one of the main topics for them is not so much the renewable, but to know the phase imbalance, to detect the technical losses, and to have a better anticipation for their next investment of the grid. If it would be better, for example, to build a new substation or to reallocate new loads to a different substation, and so on. So this is really each situation has different reason to implement such solution, but we see really a new trend and a new interest for this monitoring.
So from your perspective, would you say the business case is clear?
Alors, not in all details, because a lot of today in Europe we see a lot of project demonstrators starting like that. But also with the electric vehicle, which is coming, which should come very quickly, the low voltage grids will be very much more stressed, and we see that there is a trend also to implement a new sensor and to check really what is going on in each feeder, in each cable. But yes, it is a real trend.
We've got a detailed question actually about the RJ12. What is the length of cable between the modules?
So between, in our range, we develop a lot of cables, starting from very small to large, to longer one. So we have a complete range of different cables to be adapted to the substation. Yes. So we have, I believe it's going up to 10 meters or something like that to connect the current transformer. Yeah.
Thank you. Wim, if we could just go back to you, I'm sure there are people in the audience who are interested in doing pilots to try and solve some of the complexity that they're facing. What is your advice in getting a pilot underway?
It's the first thing is to start with a small pilot and make visible what you want to do with it. Make a vision of what is the future, what will I want to do, and try it. Try it with little steps. Think not much, I will do 40,000 stations or how many substations you have. do the little steps, and so the surrounding is going with you, and you get the power from the firm to go further and further. But the first time when the first time we started,
if you could give us some context on the DALI project. I mean, who's funding these particular pilots?
The first founding of this project was our department, and we have started with 200 boxes, about €500,000, and we believe in it. So after 1 year, we say we have built it. We have this measurements. We can do this and this, and we can show it. And I think that are the first steps to go on this way. And then you must challenge the producers, the production firms, that they going down with the prices. And you must look. We have looked to some domotica firms. We have looked to charging firms who have the same technology to find out what is a real price, what you can make for it. And so the price is sinking to €500. It was unbelievable when we started with 2,000, 3,000 euros, and we had 2-3 companies.
Okay, just wondering about the funding of the pilot. I mean, is there still a lot of innovation money around for utilities to access and try out technologies?
The funding is most of it is Enexis, but we have some subsidy from Brussels, because we have mentioned as a new project in this range. And but there's only a little small gift for this project, not the total project or something. So we get some money from Brussels and from the Dutch government, but the most of the funding is from ourselves.
And what's the experience like of actually running the pilot within your organisation? Do you have a dedicated team? Is it very time consuming? What kind of tips would you share with your peers in that regard?
Yeah, this is amazing. We started with 2 or 3 people with the pilot. After the pilot, we started for to build the ICT platform, and I think there's about 20 to 30 people who are every day busy with this project. We are now busy with the implementation for this, to installing 6,000 boxes. That means you have about 40,000 hours work about it only next year. So you speak about 41 years of work, what you will need. So it is growing and growing, and everyone in our company knows the word DALI on this moment, because everyone has connection with it. On what way?
And Nadej, from your perspective, I mean, you're involved in a number of pilot projects. What do you see is the sort of successful approach to making something like this really effective?
Look not too much to the economical effects, but think, have a vision and think we will start with it. And you must have a founder. When you have luck with a boss who will give you money for this project, you can start. And then after that, you will see that more people are involved to do this.
And for us, what we see is mainly, utilities grid operators are testing some solution in a few parts of their network, and see exactly what they can do, how they can install their IT architecture, how they can design it, and what could be all the aspects of this, and also do a test on a small part before full rollout.
So that's also that's what they say. Start with a small project, and we are now thinking that we say in the next stage, because is it ready now? Because I'm more the development then I create it more than I will finish it. And the next step in this is that I hope we go over to install in all our substations low voltage measurement system. But the step after that is that we will say we must have a connection from all charging points for electrical vehicles, that we have a connection to our substation. We will have a connection to the heating pumps. We will have a connection to the solar panels, so we can regulate our transformer. So there's when we have the voltage will not go over the threshold. So there's a lot to do, but you must do it in little steps. But you must have the vision that you want to go in 2030 to that point.
Thank you, Wim. We have an audience question actually regarding smart meters. If you have already deployed smart meters in your service territory, are they not providing sufficient information to understand what's happening out there in the low voltage grid?
Sorry, I have not heard your question. Sorry, Roos. Can you repeat it, please?
If you're a DSO and you've already deployed smart meters in your service territory, do the smart meters not provide all the information you need to better understand what's happening out there in your low voltage grid?
Yeah, that you would say yes, it must be. With all the smart meters we installed, it is private, the measurements, so we cannot have the measurement of all the smart meters. So we cannot make a program with make a sum of all the smart meter consumptions, and so we know what is going down in our low voltage grid. So we are looking to it because are there more ways to do a solution of loading of a capacity load? Yes, it may be, but in Holland it is not possible to get information from the smart meter.
Yes, and just in addition to this, we see that the data from the smart meter are private, and due to the European privacy rules, usually DSO are not allowed to have all the data and to have also real-time data. They can have also some alerts, but not everything. And one of the reasons we see that the DSO are interesting to install their own system, it is that they have their own solution, their own system to have a real view on the grid with real-time data, with dashboard, and so on. And not only, it is a complementary information to the smart meter information.
Thank you both for your comments. Wim, in your presentation you mentioned that the last black hole in terms of monitoring and it is substations and low voltage cables. Nadej, from your perspective, you mentioned that you've noticed an uplift in interest in low voltage monitoring. How urgent do you feel it is at the moment for utilities to get some kind of pilot underway or technology in place?
Yeah.
I would say, sorry.
To you, Nadej, to start with. Thank you.
Yeah. Yes, I would say really it depends of the environment and the local environment and the stress which are already there or not on the low voltage grid. Some utilities, some grids are facing a very technical challenge due to a massive injection of PV, due to massive development of different smart projects, I would say, and others are not in this urgency. And another point is the state of the network today. If it is more older system, a more older grid with older cable, or if it's more a recent one where you have all the time had new investment. And these things also are these topics are also important when we speak about the urgency to install this monitoring. But what we see already today is that now more and more are doing a pilot, and due to first the electric mobility, which could increase really the stress, and the PV monitoring. Yeah.
Okay, I mean, the title of this webinar is Monitoring Europe's Low Voltage Grid, but Nadej, do you see this as a global issue? We also have a question from the audience if you have any pilots running in Middle Eastern utilities. So is this affecting every DSO that's dealing with a modern grid?
Yes, it is really concerning a lot of countries. We are today contact, and there is some project which will start in the different places of the world, in South America, in Asia also, because they face a lot of renewables injection with, for example, a lot of due to the government politics. And in Middle East, we have also some contacts, because we see that everywhere now people, DSO, are interested to install smart meter, and now they are looking at what is the next step behind the smart meter is the monitoring of the MVLV substation. And in Middle East also they have some concern, because they are changing also their grid. Yeah. But we haven't. Yeah. Sorry. Yeah. No.
Please. I'm conscious of time. We're nearing the end of the webinar. Wim, I wonder if you could just sum up your experience and give your best piece of advice on deploying a low voltage grid pilot. What would be your best piece of advice to share with our audience today?
That's belief when you think about something. That you can do it, and I think that's amazing what has happened the last 2-3 years here. So when you have a vision about something, do it, and you will see everyone in your company goes one time with you.
Fantastic. A good positive note to end on. Thank you both for your presentations and your insights. Thank you, the audience, for listening. You can find plenty more webinars on engerati.com. And in fact, Socomec will be doing a second webinar with Engerati, so do check the website for details of that. Thank you for tuning in, and goodbye.
Thanks. Goodbye.
Thanks, audience.